All right, so that's at this location. We're on week 2, and we are going to go over this material here today. I thought we were all good. I don't know why the screen's not showing up here. Is there something on there? Computer. It's showing up here just fine. Source button. All right. So now we're all set. So the material, it's up here on this website, and for the first few weeks, it pretty much follows the book pretty well. And so that's a better backup than the slides. But today we're gonna start off by reviewing a few of the concepts that we learned last week. We learned about variables. We learned about operators, data types, and I just kind of talked about functions there at the very end of the lecture. So not really review. That's going to be our primary topic for this week. One of the things that we brought up last week was the ability of. I'll go ahead and open up Python window here. The ability for the computer to store bits of information or to store things in the computer. We call those values. Like I can store a value in a variable. So here I've got a equals 5, and that's a clue for the computer to store, or that's the statement that tells the computer to store the value 5 in a. Okay, so a is a variable, and it has a value 5. And another concept that I discussed was that any variable that's storing a value has a data type associated with it. In Python, you don't have to actually explicitly define those, but they do still exist. So that value the value 5 that's stored in a, if I ask it to report it, it says 5. If I use a function called type, I can get a hold of that, the type that it is. So it's an integer. Okay? And we talked about there's a few different types of numbers. Okay, and then there's also strings. So I can store inside a variable. I can store a string, which is a character string. That's just a shortening of that word character string. So it's storing a group of characters. So here I can print off that value, and then I can also ask for its type, and it will tell me that that variable is a string. So remember, this is the name of the variable. My name is in this case. This is the name of the variable up here, a. It can be anything. Okay, those are the labels that we give it, and they can be anything except for those few words, those few reserved words that we talked about. For example, you can't name a variable print or break or type. There's a few things that you can't name a variable. Okay, and then most of them are reserved words, so things Python uses for other things. And all variables have a specific type associated with them. Okay, they can be integers, they can be strings, and they can be also a few different other types of numbers. Before we get going today, there's one other special type of variable. I told you that numbers, there could be different types of numbers. So if I say type of 5.8, That's a float. There's one other data type that's almost a number that we're going to introduce today, and that's this. So I could say A, or I used A, but I can still overwrite it. But I'll call this something else. So X equals true. Okay. And then I could say print X, and it would write true. Okay. I can also set X equal to false. Say print X, and it'll say false. So there's this specific data type that that is either true or false. And we call this data type a Boolean. And this data type is actually really useful for logical tests. A logical test is something that we use in programming to see if something's done or to evaluate the condition of an operation. And I said that it's almost like it's a number, and that's true because we can actually take the value of X and we can add it. We can say A plus X. A plus X is equal to 5. Okay, we can say A plus false, or which would be the same thing. It would also equal 5. We can say A plus true equals 6. So in reality, a Boolean data type is being stored as either a 0 or a 1, true or false. But if it's,
excuse me.
Yeah, go ahead.
Dr. Kramer.
Sure.
Hi, I'm the facilitator here on the coast. We're not seeing your content down here.
You're not seeing this?
No, sir, we cannot see it on our end, and right now what the students can see is just a white screen.
I
apologize for interrupting you.
Oh, no problem. Thanks for interrupting me. I'm sorry that I explained this last week. Sometimes there's a bit of a delay between here and the coast. So if you have to talk over me to answer a question, I'm not offended. To ask a question or to make me aware of something.
Oh, there we go.
Okay. Yeah, I changed the IVN here, so I guess that appears on a different screen for you then when I do that?
It appears on the projector screen down here for them, and they see you on the TV.
Okay, great. All right, yeah, if that's never up, just let me know. Okay. So just to review a little bit about what I just went over, I've created a variable, a few different variables. One was called A, and it was 5, and I asked for the data type, and it told me that it was an integer. Okay, I created another variable called my name, and I put the value George, which is a string inside of it, and said, show me the value of that, or show me the data type, and it says it's a string. Okay, so the new data type that we're talking about now is this new data type of a Boolean. And a Boolean can either be true or false, and that will evaluate when we're working with numbers to be either a 0 or a 1. So a Boolean, strictly speaking, is a true or false value, but it will evaluate to a 0 or a 1. Also, conversely, if I treat a number like a Boolean value, meaning true or false, it will always treat it as though it is true if it's not 0. Okay? If it's 0, it'll treat it as though it's false. So numbers and Booleans, you can go back and forth between those two. You just have to remember that simple rule. Okay? Boolean means that it's either true or false. And so if you treat a number as a true or false value, the rule is if it's 0, it's false. If it's anything else, if it's any other value, it's true. Okay? It's how you would treat a 0 in multiplication. So what everybody knows that if you multiply anything by 0, it becomes 0. All right, and if you add anything to 0, it just is the same as that value. All right, and the reason that reason why this is an important topic for today, logical operators, specifically how they can help us in concepts called branching and looping. Okay. So we've discussed the primary data type that's important for, oops, that's another window head up. Okay. Where's my, there we go. We discussed those. We can evaluate different conditions, and a condition is a specific type of statement, to see whether it's true or not. Okay, one of the most common conditions that we'll test is whether things are equal to each other. So here I have A is equal to 5, and I could say B is equal to 7. Okay. Well, if I ask it, does A equal B? That's something that I might do. Okay, does A equal B? I could say print A equal to B. A does not equal B. Okay, A equal B. It says false. Okay, they're not equal to each other. Okay, so it's a logical test. Do A and B equal each other? No, they're not equal to each other. That's false. So there are a specific type of operators called logical operators that return Boolean values. They return values of true, or they return values of false. And this is one of them, equals. And why couldn't we just use print A equals B? Well, the equal sign with just one equal sign is already taken. Okay? So one equal sign is a cue for the Python interpreter to store the value on the, depending on where you're looking at it, if you're looking at this page, the value on the right in the variable on the left. The equal sign is a cue for the Python interpreter to evaluate whether or not the operator, the values on each side are equal to each other. Okay. So there's a few others. We could also ask the computer whether or not they're not equal. So print A does not equal B. That's true. A doesn't equal B. So if we could ask, does this thing not equal this thing? And the answer there is true. There's a few others. There's a few other ways to do things. We could also ask if A is greater than B. So in this case, we just write the greater than sign. A is not greater than B. We could also ask if A is less than B. Yes, A is less than B. Okay, that means that 5 is less than 7. That evaluates as true. It is less than 7. Okay. We can also do greater than or equal to, and we can do less than or equal to by just putting an equal sign after that. Print A greater than B. Okay. As I said before, you can put you can leave the spaces out between the variable names and the operator. Okay, but you can't leave the space, or you can't add a space in the middle. Like this doesn't work. Even with a space here, that doesn't work. Okay, that's invalid syntax. So the operator is those two characters together, the greater than or less than and equal to. Okay, so you've got equal to, not equal to, greater than, and less than, and those are enough to do a lot of things. So those are logical operators that will allow us to compare to compare the values that are in variables. And most of the time, well, not most of the time, a lot of the time, we're dealing with numbers, but we don't have to be dealing with numbers, especially when we're talking about equal to or not equal to, right? So let's look at, we could say print George equal to George. All right, that's false. Why is that false? Right, exactly. There's the G isn't capitalized, and I already told you last week the Python is case sensitive. So those statements don't evaluate to true because they're not the exact same string. However, if I wrote, whoops, I wrote George equals George, both capitals, they do evaluate to true. Those two statements evaluate to true because they have those two variables, and I didn't frame them as variables, but still they're stored as variables and then compared. Those two variables evaluate as true. So let's create a new file, okay, that will demonstrate this. So if I go print, or sorry, I'll call these better names. Name 1 is equal to George. Got to be in quotes. Name 2 is equal to George without the lowercase, without the uppercase, and I ask it to say, I'll just call this EQ, that's the name of another variable, is equal to name 1 equal to name 2, and then finally print EQ. So what I've done here is created two variables, one called name 1, one called name 2, and then I do this operation and store the result in here. Okay, so this operation compares these two names, and I'm storing the result in a variable called EQ, and then I'm going to print it. So if I go ahead and run this example, I should get the same result. Okay. I'm going to call this, store this in the directory I'm working in, courses, week 2, example 1.GY. Okay, and the result is false. All right. Okay. So we've gone over Boolean expressions, logical operators. Logical operators compare different Boolean expressions, which are these equal signs or not equal signs. One thing, kind of getting a little bit off track here, well, away from the lecture note there, is that what if we wanted George and George to be equal to each other? Okay, well, how could we solve that problem? One way that we could do that is to just, if we had a way to magically change the case of every letter in the variables, and then do the comparison. Okay, so we're getting a little bit ahead of ourselves, but if I took the name George, this variable, and changed everything to uppercase, what do I mean by that? Well, if I wrote something like this, George, if I changed both of these to uppercase, it would look like this. Everybody see what I mean there? If I changed both of those values to uppercase, that's what the result would be. It would look like that. Okay. Everybody remember what that pound sign does in Python? Okay, comments. So those are just comments. So if I changed this value and that value to uppercase, I would get this and this. Would those evaluate true? If I did the same expression, do those equal each other? They do. They do actually. And so if I had a function, and I forgot what it is. I think it is just upper. Let's see if this works. Yep. Okay. True. So this is a specific function called upper that converts a string to uppercase. And we'll talk about functions in greater detail here in just a second, but it's a function just like the type function. The type function was a function. Okay. All right. So that's an example of another function. Okay. All right. The next concept that we want to introduce as a direct branch, I'm going to use the word branch here, as a direct branch of what we've just discussed, these Boolean operators. The first concept that we want to do is called conditional execution. And all these A, B, and C, conditional execution, alternative execution, nested and change conditions. Change conditions are really the same basic concept. So in lots of computer programming languages, we have this ability to do what we call branching. And branching will execute different sets of code dependent on a condition. Okay. So let's say instead of printing this off here, I'm going to do something like this. I'm going to say if, I'm going to change it up here. I'm going to say if, and I'll go back to my other code. I'm sorry. So if name1 is equal to name2, then I can print something. Let's say print those are the same names. I'm just going to put a print statement down here that says done, so that we know that it finished the program, and run this. What do you suppose is going to happen? Well, right now it's just going to print done. Okay. Even though I have this statement in my code that says print those are the same names, it never executed that line of code. And why did it never execute that line of code? Well, because I used a new statement that we're just discussing now, this if statement. An if statement says if this condition is met, then and then you have a condition. If this condition is met, then proceed and do everything. And in Python, it's everything after this indentation. That's how I make the indentation. So if I come back out of the indentation, it'll still do that. But it's only going to do the things that are indented if this statement is true. So if that statement is true, do the things that are indented. So to change this to make sure that it works, I could change that line of code. So now if I run this, if I change George to uppercase, run it, it says those are the same names. So it tests those two conditions, or sorry, those two values. Are they the same? Yes. Then it says those are the same names. Okay. So that is this this concept here, conditional execution. All right. Now, what if I didn't want to leave the user hanging? I wanted to let the user know that they either got the same name or they didn't get the same name, because so often a Boolean expression is either true or it's false. Well, always a Boolean expression is either true or it's false. Okay, It's one or the other, okay? So I want to let the user know that they got to one or two different places. I can do that. I use the else statement. Okay, the way that the else statement works is if this condition is true, it runs this code. Any other condition is true, it runs this code. Or in other words, if this condition is false. So in this scenario, if this is true, run this code. If not, run this code. Okay. All right. So now, if I change this back to George, I run it. I've got, those are not the same names. Or even if I change this to Lloyd, and I run it again, George and Lloyd are two different names, so it says those are not the same names. Okay. If I change this back to George, I get that they are the same names. Okay. Conditional execution. So it's going to run one or the other. All right, sometimes it's useful to actually gather our inputs from some other source. I think I should show this before I continue here. In the lecture notes, we've got this way down at the bottom, but there's a specific function that will actually wait for the user to input something. And instead of having my names be equal to values, I could say something like this. Okay. All right. This is a specific function that provides a prompt and waits for the user to enter something. So this raw underscore input is going to wait for the user to input a value, and then it's going to compare that value to this to George. So if I run this now, it'd be kind of like a password program or a username. Okay, what's the name? I'm prompted. The computer is not going to continue until I type something. So if I type in George, it takes that value and inputs it into the program and says those are the same names. So it takes the value that's input by the user. Okay, so that makes it a little bit more exciting because it's not always. Oops. Sorry, that was a mistype on mine. It's not always the same name. It's not always George, so it's whatever was input there. Okay. So this could be a value that we pulled out of a database. Like I said, this could be a computer program that checks to see if a username and password are correct. And so if it's right, then you could say something like correct. And if it's wrong, you could say, no, that is not right. Something like that. Okay. All right. So that's conditional execution. And we've also covered now alternative execution. But what happens if we want to do something like test for a specific value, but we also want to say that it's okay if the user, well, for example, with the upper and the lowercase issue. We want to tell the user that's the correct name, but you need to capitalize or something. Well, we can do that. There's a condition here. We can change this from else to else if, and then add a condition. Else if name1.upper equals name2.upper. and say, instead of correct, we'll say, you typed the same name, but didn't and then finally, we could also write else wrong. Something I'm just going fast for. Okay, so now we have if something's true, and we can say else if, and then finally an else statement. So this is checking for multiple conditions together. Okay. It's capital. Run. Invalid syntax. All right, Python. Sometimes I get confused in my computer programming. Python prefers or only accepts the else if statement if you actually combine them into ELIF. But that's what it means. It means else if. Okay, other programming languages, you type else if. With Python, you just type ELIF, which means else if. Okay. All right. So I'm going to run this and type the name. If I type George lowercase, I'm going to get, you type the same name, but you didn't capitalize. Okay, if I run this again and I type in Lloyd, it's going to say that's wrong. If I type in George, say that's correct. So I did it all. I did that, all the different options. If you think about it, I could write it something like this. So this is a shortcut for this. If I typed else and then did it like this. So the LF is a shortcut for that statement. This would work exactly the same way. Okay? Else, do that. If this, and then else that. So that's a shortcut. It means the exact same thing. If I run this, I get the exact, I won't demonstrate all three, but I'll get the exact same result. If I type in George lowercase, I'll get you type the same name. Okay? That's a shortcut. Else, LF is a shortcut for else. And the indentation is important. It's one thing that I personally like about Python is that the indentation is important, so it helps you organize your code well. You know, you put the indentation in where it needs. It actually doesn't matter how much you indent. Like I could indent maybe one character and run the same code, and I would get the same thing. It would go to Lloyd. So consistent in the indentation area that matters. So everything below this this statement, this else statement, has to be indented the same way. So if I put an extra indent here and said print, you know, you are still wrong, I'm going to get an error here. Why do I get an error? Because it says there's unexpected indent. It doesn't understand how this indent is different from this indent because it's different and it doesn't know what you're trying to do. So the indentation under every colon has to be kept consistent. Okay. So by default, if you type colon and press enter in this IDLE program, it creates that indent for you and actually creates it as spaces. So one thing that kind of gets people by accident sometimes is if they press enter and then for some reason, you know, they press backspace and then, oh, I did want to add code there. And so then they press tab, okay? So in IDLE, it takes care of it for you. See how these are, even though I press tab, these are spaces, okay? But in most text editors, it doesn't work that way. And so if I then typed in a statement, Okay, and then I tried to run it. It'll work in IDLE, this program, but if you could write your Python code in whatever program you want, but just be aware that most of the time a tab and a space aren't equal, and a tab and 5 spaces aren't equal. Those aren't equal things. But in IDLE, it doesn't let you actually use tabs. It takes over for you, and when you press the tab button, it turns it into 5 spaces. Okay, that can be a gotcha when you're trying to write Python in a different text editor. So just not a super important thing, but just something I thought I'd bring up. All right, so we've got nested conditions. I could write else if all the way down forever. That's what we mean by a chained conditional. Okay, you can continue to say if this is true or if this is true, and that way you could really test. Let's say there were 10 possible things that you wanted to test for. Okay, so enter a number between 1 and 10 as an example. Okay, if it's 1, do this. If it's 2, do this. If it's 3, do this. If it's 4, do this. Okay, there might be some need for that in a program. It might be that we're just saying, is it less than 5 or is it greater than 5? Okay, but we might want to test for every specific value, and that's when you would use a chained conditional. Okay. All right. Okay. All right, looping. Okay. The 2 main topics that we're going to discuss today, one that I mentioned was this branching, and the second one that we're talking about is looping. Looping is the second topic that we're going to talk about today. Looping is a topic that allows us to repeat a specific action, to do something over and over and over again. Okay, and there are really 3 different ways to do looping. Okay, and for this class, we're really going to focus on 2 of them. In fact, until we get further on into functions, we won't talk about the 3rd one. I'll just briefly mention it, but we're not really going to spend a lot of time on it. So we're going to talk about the 2 others, the formal ways to loop. One of them is a for statement. Okay, and a for statement will loop over a specific type of variable that's really a group of values rather than a single value. Have we talked about any values, variable types? We talked about any data types that are really groups of values yet? Okay, what of the types that we've talked about are really groups of values? Is an integer a group of values, or is a single value? Anybody? It's a single value, exactly. All right, is a Boolean? No. Okay, it's a single value. What about a string? Is a string a single value, or is it really a group of values? Remember, I kind of hinted at the fact that why is it called a string? It's a string of characters, okay? And it really is. It's a group of values that are, so it's a data type. It's a specific data type called a sequence that we'll actually explore more about next week. And it's really powerful to be able to use sequences, but a string is a type of sequence. And so the for statement can be used to say, give me every item in a sequence in order, just give it to me, and I'm going to do something to that. Okay. So I'm going to show you what I mean by that, and we're going to use that first. Okay, I'm going to go ahead and save this, file, save. So now this will be example 1. And the next thing I'm going to do here is save this as example 2. And then I'm going to delete everything except for name 1. Okay, name 1 is going to be my raw input. So the for statement, it lets me loop through every value in a sequence. So I can write print name 1. What will happen? It'll just print whatever the user types, right? But if I put this in a for statement for x, actually, let's use words that make it more descriptive. For char, I'm going to use char in name 1. Char stands for character. For character in name 1. Okay. And we could just say print char. Okay. So now it's going to go through and print character by character the characters that are within name 1. So I'll run this, and you can type in whatever you want. You can type in your name. Run this, you type in your name. I'm going to type in, I don't know, a longer name. Actually, yeah. I can just type in whatever I want. I can type in something like that and press enter. And what it's done is first it executed this line where it just printed the name by itself. And the next thing that it did was to print every letter as it came across it. So what happened? Well, char is really a variable. And so what it's doing is it's entering a loop. This loop runs for every character that's in name. So the first time through, char equals D in this case. The second time through, char equals F. The third time through, char, car, or however we want to pronounce it, equals K, and so on. So every time through, it equals character, char. All right. Let's make this do something useful. Okay. Because this is oftentimes what gets done in computer programming. Count is equal to 0. Okay. Oftentimes, at the very beginning of a loop, you set up some conditions, some initial conditions, and you modify those initial conditions during the loop in order to find something out. Okay. So let's tackle the problem of counting how many E's there are in people's names. So I'm going to write a computer program that will allow the user to enter their name or any other name, and this computer program will just count the number of E's in your name. Okay, it's at this point it's not extremely useful, but we're going to get to there. By the end of class today, we'll be calculating the length of lines and stuff like that, which could be pretty useful for GIS. All right, so I need to set up my initial condition. Before I start counting something, I don't know how many there are. There are none. Okay, by the time I'm done counting, I'm going to reach a number. Okay. And I'm going to report that number back to the user. So if I go through here, the first time through, car is equal to something. Okay? And I want to check how many E's there are. So what could I do to check to see if car is equal to E? I could use what type of statement that we've learned about so far? If, right? So we could say if char is equal or just equal? Yep, equal to E. I'm going to put a big E. Then I'm going to take count and add. Count is equal to count plus 1. So what's going to happen is that it's going to go into this for statement. It's going to get the first character. It's going to see if it's an E. It's going to see if it's a capital E. Then, if it is a capital E, it's going to increase the count by 1. And it's going to add that to the count. So count will be increased by 1. So count will be 0, but it'll add 1. So count will then be 1. And if it finds another E later on, it'll increment count by 1. And so then count will be 2 and so on. So we'll always know how many E's were in the letter. Now we do have the problem in that we don't know that the name 1 is going to have capital E's or lowercase e's. Okay. So we could solve this in 2 ways. One is to use the upper statement, or we could test for another group of Boolean conditions. Okay. And those are statements that look like this. We've got and, sorry, we would say or CHAR is equal to E. We need a parenthesis around all of this. Okay. What this is saying is if the character is equal to E, or if the character is equal to lowercase e, and we don't need that space that I just added, but I've told you I like to put those spaces in. So if it's a lowercase e or an uppercase e, increment this count variable. That makes sense? So we've got the ability to increase the count whether or not either of these are true. There's only one other one that's really important. There's this keyword and. Okay, these are logical. Basically, these logical operators allow us to glue multiple Boolean statements together. Okay, so we've got Boolean statement 1, Boolean statement 2, and it glues them together. And if it's or, either one can be true, and the entire statement is true. If it's and, they both have to be true for the entire statement to be true. Okay? All right, so or is the one that we're going to use because we want it to be true whether or not it's uppercase or lowercase. We want it to and then what do we need to do in order to tell the user how many E's there were? Okay. We need to print that. So we print count, and we'll get the user, we'll tell the user at the end how many E's there were. Okay. So we run this, and if I type in George, press enter, I get a value 2. It's telling me that there were 2 E's in there. And even if, you know, I run this and I type in that my name is Aaron, and it's spelled with the E, I get 1. Even though the E was capitalized, it still works. Okay. All right, so that is that's a condition. We've got a condition. Now we've got a loop in there, and we've got some Boolean operators, and we've got some logical operators to tie these Boolean operators together, and or there's one other one that's called not, and you don't use not to glue 2 statements together. You just use not to change one to the other. Here, I'll show you here. If I just wrote not true, it actually true does matter if it's capitalized or not. Not true equals false. Not false equal to true. And so you can use the not statement. It's kind of similar to like how you'd use not equal to. Okay, if you just wanted to check for the opposite condition of something, you could use the not statement. All right. Okay, we'll go over the for statement a lot more next week when we start talking about sequences. Okay, lots of things are sequences, and really in ArcGIS we can start evaluating a record in a data table as a sequence. Okay? A sequence is just a group of values. We can define it in lots of different ways, and so we could say, okay, for every record in table, I want to do something. I want to calculate the total population. So for every record, take the take the population and keep adding it up. Okay, instead of using count, we could just set count equal to 0, and we could change this from pop to, you know, this could represent population. We'd be adding up population plus the current pop. And we'd be adding up the population values. I'm going to revert that back, because that was just an example. So that's something that we could use a for statement for, is to go through every record in a particular data set. Okay. The other type of looping that we'll use, that we'll encounter a lot, is called a while statement. And it works a little differently. It continues until a specific case has been made. Okay? And I'm going to modify this program to demonstrate the while statement. Okay? So I'm going to go way up to the top here and say, do something like this. I'm going to say while, actually not right there. Okay. While, make up a new variable. Proceed. While proceed does not equal stop. Then do all this stuff. Okay. Actually, I'm going to change from proceed to name one. I don't need to, I was trying to make it general. So what I'm saying here is, well, name one does not equal stop, do this. In other words, what I'm trying to say is, if they enter stop, don't. Now, what I need to do with the while statement is that I need to be able to break the condition. Otherwise, it'll continue forever. In fact, I'll demonstrate that right now. So I'm going to run this module. And I'm going to type in George. And I press enter. And it's just going to keep going forever and ever. It's printing off George forever, because it's going to print this. And then it's actually going to not even get to this part, because while it's inside this loop. Okay, I forgot to indent this. I should have indented this as well. So I'm going to run this. So this is what it should look like. So now if I type in George, I get George 2 forever and ever. Okay, I've got to get out of this while statement. The while statement has the ability to continue on forever unless you get the statement to change. So one way to do that is to statement that will allow them to change the value. So now if I run this code, it's going to allow me to continue to enter names, and it's going to report how many E's there are in that name. So I wrote George, I could type in Aaron, I could type in April, I could type in Bob, I could type in thing. Okay, those all have 0. If I just type in a bunch of E's, it gives me 34 E's. Okay, I can type in whatever I want. Right, the user has, but if I type in stop, I want to stop. So I type in stop, and what happens is that it's executing this statement, and it gets back up here, and it checks what the name is that I entered down here every time. And so if it doesn't equal stop, it just keeps going. But as soon as I type in stop, it checks this statement, finds out that it's true, and allows us to stop the program. Okay, so that's the while statement. Okay, while name one, and then it continues. So the while can continue on. Okay, updating variables. So here we talked about this last week. Remember, you can actually take a value, and you can take a variable and update the value that's stored in it, and that's what we've done here. So right here, name1 equals whatever the user entered the first time. Then they came into this loop, and until we got to this place here, name1 still equaled that. Well, at this point, name1 is equal to whatever the user enters the second time through the loop. And so when it gets back up to the top, it checks and says, okay, does name1 equal stop? No, it doesn't. So it continues on until the user types stop. Continues on until they type stop. So that's what we mean by updating variables. So that's an important, that is an important, a key thing, a key concept in the while statement is that there's the ability to update values and change those values. You can store different values in the same variable and it actually writes over them. It gets rid of those values and stores the new value in there. Okay. Finally, the last big concept that we want to talk about is making our own functions. Okay? Making our own functions. Okay. I'm going to go ahead and save this again. Okay, and I'm going to save it as example 3. I'm going to write example 3 and save that. So you'll have all 3 of these examples. So this example used a while statement, and it uses a for statement, and it uses an if, and it uses Boolean and logical operators. It uses everything that we've talked about up to today. However, this this program does not use a function. Okay? There's no functions listed in this program. Well, it uses any functions that okay? We could write our own function. Okay? The way that we use the def for define. So we define a function, and the function could be called count letter we want. Define here is a variable in and of itself. Okay, you don't have to think, you don't have to wrap your mind around that yet, but a function is a variable. And in this case, our variable name for this function is count letter. We're going to write the same thing as this. In fact, we'll just copy and paste the code up there. So we're going to count letters, and this space here, I'm just going to type in here is where this is where the parameters go, and this is where the code goes for our function. So all functions have those 2 components. So first of all, they have a name. In this case, we called it count letters. Then they have the parameters. The parameters of a function are the inputs to the function. Okay? We pass off inputs to the function. We could write a really simple function. In fact, yeah, let's do that. Let's write a really simple function first here. We could write a really simple function that I'm gonna comment a second. I'll write a really simple function just called add 10. And then I'm going to say, okay, the parameter that's going to be input into my function is going to be called x. And I'm just going to say x plus 5. Okay. It's called add 10. And it's just going to add 10 input. Special function. And in fact, I should really, I'm going to save this. I'm going to save this, and then I'm going to file save as example 4 and come back to this one. Okay. Got my example 4 up here. I'm just going to delete everything so that we can function a simple function first. So my function is going to add 10. If I call this function, it's really simple to do. I can just say add 10 and give it the value of 4. So what's it going to return? Return a 14. So if I run that, I get the value of 14. So add 10 is a function. I'm sorry, was there a question on the coast? Okay, so I'm adding 10 to x, and I get 14. So this function does is it adds a result out. It's a really simple function, but it is a function, just like the raw input function or the type function. It does, in this case, though, it prints that value out. Most of the time, it's much more useful for the function to actually return the value and have the program take care of reporting a value back to the user. The main program take care of that, okay? Because if I were to actually say A is equal to add 10 for, now if I print A, watch what happens. Okay, 14 has a value, but A doesn't have a value. It doesn't work like a function. We're familiar with functions in math, right? A function in math would return a value. We'd say, you know, y equals x plus 2. Well, in this case, x plus 10. Y is equal to x plus 10. Well, if we give the value of 5, we'd expect y to equal 10, right? Well, it doesn't do that unless we explicitly tell it to return a value. So we can do that by typing return as the command. So return will actually take the value of x plus 10 and give it back to this. It'll say 14, or if we change the input value to, it'll say 77. Okay. So now the value of A is reported back to the user in the main program. Okay. So this is the stuff in the function. This is the stuff we can call the function however often we want to call it. Okay. We can call our function again here. E is equal to 42. Print B. Run. Function is reusable. That's one of the very anything that we want to do multiple times, we can do multiple times through functions. And in fact, you can save a function in a whole different file. Okay, I could save a function in a separate file, and if I call that file my math functions, okay, then I can always access those functions by typing my math function dot, then the name of the function, in this case, add 10. Another function called subtract 20, I could say my math functions dot subtract 20. Okay, so that's really what's going on. You've seen that a few times in the code so far. I put a dot. It's that there's a function stored in another location that you're referencing. I think we did, I think we used math.py, right? We said math.py. That's not going to work. Import math. It's capitalized, right? Nope. Import math. So what we're doing there is saying, okay, go get that file called math, and now we have access to a bunch of additional functions. Help math. And these are all the additional functions that we have. So these functions are defined inside that file called math, and we're all a little bit familiar with all these functions that are listed here. Tan, cosine. These are all functions that we've heard of before, at least, right? Well, maybe not all of them. L gamma, I don't know. Natural logarithm of the natural. So these are all functions that are defined in that other file, okay? So that's one powerful thing that we have, is the ability to write functions that we can reuse. And it actually makes our code better. If we have a complicated thing that we want to do, we can group that code together and call it a function. So one of the good things about functions is repeatability. The other good thing about functions is they allow us to a certain piece of our program and call it something that makes sense. So we can see how add 10 is a good name for this function. It's a pretty simple function, but it adds 10. Okay. All right, so I'm going to save this and go back to our other example. Oh, one other thing I want to make sure that everybody knows is functions return one value. They can only return one value. You can't have functions return multiple values. So you only get one return statement. And actually anything under the return statement is dead code. Okay, that's from this right here. Anything below the return statement is dead code. The book calls these fruitful functions. A function that has a return statement is called a fruitful function in the book. So if I write something like print howdy right here, and I try to run this code, I'm never going to print howdy. Okay? The reason why I'm never going to print howdy is because it's after the return statement, but it's still inside the function. It's still indented. It's part of the function. So it never gets there. Okay, it's dead code. The same thing would happen if you had a statement that always evaluated as true. You would never run anything in the else statement. Okay, a return statement stops the execution right there. You can actually have multiple return statements. Okay, if we had an if statement inside of our function, we could say, okay, well, if this condition is true, return this value. And if this condition is true, return this value. We could have a function that returned multiple values. Okay, does that make sense? So we can have multiple return statements, but anything once it hits a return, it's done with that function. It's gone. Okay. I'm gonna leave this in, but I'm gonna write this is dead code. All right, so I said they called this a function, a fruitful function. The opposite of a fruitful function is a void function. A void function does not return a value. Okay, a void function, that's a computer science term. Some programming languages actually require you to define whether a function is void or not, and Python does not. Okay, but if it doesn't have a return statement, by definition, it's a void function. It doesn't really does something. Okay, so that's dead code. There are some examples that we'll talk about more next week where a void function would be useful. Okay, but they get a little bit into dealing with certain data types. For example, well, here I'll give you a little preview. Let's say we have a group of items, and we want to sort those items. Well, if we handed off those items to a function and it sorted those items, and once it did its job, they were sorted, it wouldn't have to return anything. It doesn't have to return the list back because we still have a reference to that list. Okay, that's an example of a function that you wouldn't really need to have a value. It sorts them. It's basically what it does is it opens up the box, sorts the values, closes the box, gives it back. Okay. If it did take a copy and give it back, that would be acceptable. Wouldn't have to. Okay. All right. Which does bring up an important point, okay, that I do want to talk about this week. What's the value of x right here? Like if I wrote print x, what's going to happen right there? Anybody have a guess? Anybody that maybe taken a computer programming class before? What's going to occur? I'm going to run it. I get an error. X is not. Okay. Do you see x here we definitely define it up here. I mean, we say x is going to be equal to 67, and here it's equal to 42. Why do I get that error? Well, that's one special thing about functions. Okay. You know, what's the saying on the Las Vegas commercial? So it's something that stays in. I'm butcher the statement right there, but what happens in Vegas stays in Vegas, right? Something like that. Well, any variable that you create in a function stays in that function. It's only in the function. So a variable that you create inside of a function is not global in scope. Global is the problem. It's not known out here. Okay, this right here. When we're in this part of the program, we're in the global. Any variable that gets created, we know about it. Okay, but if it gets created inside of a function, we don't know about it in the rest of the world. Okay, all right, so we've got x doesn't exist out there. It only exists there. So we could even call it the same thing. We could call it a here, and we could run this, and if we, like, let's print a again here. Some people might think, okay, at this point, a is equal to 67. A is equal to 67. It goes in here, and at this point, a is plus 10. In fact, let's change this so it looks like this. So if we said a, sorry, let me do this. X, a is equal to x, and then we'll change this to a. Yeah, just return a. So you see how this should be the same function. So we just added a statement in here. But a here is going to be equal to 77, and then we're returning a, and so a is equal to 77. Okay. B now, we give b to this function. B goes in, which is 42. 42 plus 10 is 52, and a, it should now be equal to 52. We return a, and it prints 52. Okay, so if things stay inside of the functions, this should still be equal to 67. If things inside the function change, we're going to run it, and we'll see that it's still 77. Okay, so this a is a different a, is the point I'm trying to get across. Okay. Any variable that's created inside of a function only exists in that function. All right, so I should call this something like plus 10. Just for confusion's sake. If I want to, because it's a different a. Okay, it's the a inside of that function. It's not the a in the global scope. The opposite of global is local. Okay, variables that you create and manipulate inside of a function are local variables, local to that function. Variables that you create in your main program are global. However, you can't, like, let's see what happens if we say print b or print a, because now a isn't defined in the function. Okay, a is not defined. Okay, a is not defined as part of the function. It's only available to you out there in the main body of the program. So they don't go back and forth to each other. You have to pass it if you want it to get that value, which we already have done. So the variable a has the label x inside of this function. We could call it a if we wanted to, that they're two different pointers. Okay, they're not the same. Okay, I believe we've covered that enough. Let's go back and open the example 3 here. Okay, this is the example 3, and I'll go ahead and delete my add 10. And we're going to write a function that does this. So what are the parameters that we need? What I would like to do is make our function generalize our function. we're going to generalize our function so that it will accept any character string, and it will accept any letter, any single letter, and it will find out how many of those letters are in that character string or that string. So if I type in George and I type in G, it'll count the G's in George. If I type in Bill and I say L, it'll count the L's in Bill. Okay, how many L's are there in Bill? So that's the function that I want to write, because that's going to be more useful. It's not just going to count E's. It's going to count any letter. So in order to do that, how many parameters do you suppose I need in my function? Think of how many parameters I'll need in my function. But parameters are my inputs. Okay, in my inputs, think about what I'm going to do with my function. My function is going to compare characters to a string. So how many parameters, how many inputs am I going to need? 2, exactly. And those are going to be those two values, the string to test and the letters. So, or the letter to test. So I'm gonna type those in. What should my variable names be? Maybe test string and CHAR. Okay. That might get a little bit confusing because I'm going to copy and paste this. So I'll type in this. I'll type test character, test CHAR. Okay. All right. Next thing I'm going to do is simply copy up this code that does the magic, that counts the letters, and paste it up under here. Okay. Control C and Control V do copying. There's also under Edit menu to do copy. I'll let you have a few seconds to make sure that your code, you get that up there. All right. So what are some of the things we need to do here? Well, first, we need to change the name 1 to actually be what in this case? Name 1 is going to be inside of our function. Name 1 has a new value. It has a new name. What's the name of name 1? It's going to be the test string, right? Test string is what we're going to give it. So for every character in test string, we're going to compare it to E. And do we want to compare it to E? We want to compare it to our test character. Okay. So let's change this. And do we know if the test character is going to be upper or lowercase? No, we don't. Okay. But one thing we could do is if we want to test for upper or lowercase, we could leave it like this. We could just say, okay, well, if it has to be the exact same character. I'm only testing upper characters, uppercase and lowercase. Okay. If it's George and you type in G, little g, it's going to say 1. Type in Aaron and you type in uppercase E, it's going to say 1. Things like that. Okay. Or what I could do is convert both of them to uppercase. So I could do this and dot upper. So now it's going to convert both to uppercase, and I'll have the same effect as doing that or. So whether or not it's already uppercase, it's going to be converted to uppercase. I could do the opposite. I can convert both of them to lowercase. But this will have the same effect. It'll convert those to uppercase, and so it won't matter if they're upper. Okay. All right, I'm going to delete this print count statement in favor of a return value. I'm going to return count. So now, when it loops through this, when it does this loop, it's going to count up count, and when it finally finishes the loop, it goes through all the letters, in test string. It's going to return the number that it found. Okay? And then I should probably print that out. Oh, actually, I need to call the function. That's one thing that I need to do. Okay, call the function. All right, I called it count letters. I got to do that, count letters, and then I give it the test string, which is going to be name1, and then I'm going to give it the character, which in this case I won't let the user enter that. I'm just going to type in E as the character. Okay, so it's still going to count E's. So at this point, the function should run exactly like the old program worked. And you'll notice that there's actually a few extra lines of code. This is a little bit longer program than it was before. Okay, really, there's only one extra line. That's this line right here. Well, two extra lines because we have to call this function. So these are the new lines of code. So writing functions isn't always worth it. Okay, if we're writing a really quick program, we may not need to write a program, a function, but it does help us to keep it a little bit organized. Sorry, was there a question on the coast? Okay, run module, type in George, I get, oh, I don't get anything. Why don't I get anything? I still don't get anything at all, okay? I took that print statement out, okay? All right, it's 4:34, okay? We're going to take sorry, not 4:34, 6:34, all right? So, this is a 2-hour class. We're a little bit, we're getting close to the end of the lecture period. So we'll take a little break, and what I want you to do is think about, we're going to take a 10-minute break and think about how I can modify this program to get it to print the count out. Okay, the count is stored up here. In fact, it's returned. Okay, but how do I get it out here? I'm going to add a print statement. In fact, I'll put one more statement in here. Print the count, or I'll just call it C. Print C. So how do I modify this? It's not hard. Some of you probably already have it in your head. How do I modify this code so that C is actually the number of times that it found the E in this code? How do I modify that? Okay. How would I modify this? How do I modify this program so that it would print the number of letters? In fact, what I want it to do is, instead of printing C, I want it to write the number of E's is, and then prints C. Okay, I want it to do that. So we'll meet back. I know it says 4:35, 4, 5, 6:35. We'll meet back in 10 minutes, 6:45, and I would like somebody to come up with the way that we could do that. So instead of printing out C, I want to print it out. I want to print out the letters. I want to print out. There are X E's in here, and an X should actually say 2 or 3 or 4 or 5. Okay. Remember from last week. I'll just give you a hint. Remember from last week. What happens when you add two strings together? Okay, that's your hint. That's one of your hints. It's one of the things that will help you. What happens when you add two strings together? Anybody know? Yeah, it concatenates those two strings, right? So in 10 minutes, I'll be back. I just need to get to the restroom real quick. And then we can continue. And then we'll do we'll make sure there's nothing else on the lecture, and then we'll do the lab. We'll go over the lab assignments.
Well, the chocolate, that's Python.
All right. I guess it's. I can hear you. Is it Daryl?
Yeah, is that video that you made on YouTube that you came out on YouTube last week?
I did. I watched part of it. I can show you how to get to it. I believe. I mean, it is on my account, and I'm doing it again this week. So let's do the internet here. That's the one that's recorded. I see it on Google. If you, pretty sure. That's the internet. It does seem, but this says that it's running slow. Let's. What I'll do now is let's finish up this topic, and I'll see if I can pull it up in the break between lecture and lab. Well, I'll introduce the lab, and then we'll do that. That's a great question. Any other questions? Okay. All right. Okay. So I said the first thing I wanted to do was to evaluate here. I'm sorry. Was to be able to return. First, let's just take it to this point where we want print C. We want C to be able to be the return value. Okay. How would we do that? Anybody got an idea? We want C to be the number that is returned from that def count letters. So C has to equal that, but how do we do that? You're right. I mean, you're right. C. So we need something. We need a C equals something, right? All right. Where can we? because C has got to equal count somehow, okay? Does anybody remember what happens? Let's go back to this code. Right? Let's go back to this code real quick, okay? Let's study this here. Study this line of code. What is this? That's the name of the function, right? And that's the value that we feed into the function. And how do we get the result? We just, this line right here, we just say A equals to the function because the function returns that value. How are we doing that over here? How do we get C to equal this? Does this make sense? That's what we have to do. That's the only thing we have to do. Now C will equal that. Okay, if we run this, we get what is the name, we type George, and we get that value 2. But I said we didn't want it to be 2. We wanted to have to write it out. Okay, so how do we do that? Well, we could say the number, oops, has to be in quotes, the number of E, maybe I could write E's, make that mistake, E's is C, okay, A plus, okay. All right, there's a few problems here. The way that we tell something is a string is we use quotes. However, one way we can get around this in Python is that Python doesn't care if you use double quotes or single quotes, you just have to be consistent. So if we use single quotes out here, then everything inside of that is going to be quoted. See how the colors changed back to normal? I used single quotes out here. So these double quotes become part of the string in that case. If I use double quotes in both places, it gets confused. Because what it says is, this is a string, and this is a string, and there's an ES in between. That's confusing to it. If I put the single quotes, it says, oh, okay, you're saying everything inside the single quotes is a string, and these double quotes are part of the string. All right. If I try to run this, I'm going to get an error. Let's see if we can interpret the error. Concatenate string and int objects. Cannot concatenate. So what do we have to do? Okay, C is actually a string. I mean, we want C to be a string. It's actually a number. Okay, so there's a special function in Python that will allow us to convert it. I think we discussed that last week. We didn't go over it in detail. So if I go str C, that'll convert C to a string. So now if I run it, I run this module, I get George, and it says the number of E's, I don't like that statement, the number of the count of E is, yeah, let's do that. I'll type in George, and I get the count of E is 2. If I type in, you know, Will, get none. What's the name that has a lot of E's? Bob, no, well, Robert has 1. Robert, I'm going to get 1, okay? My function works now. Everything works in its entirety. I've got my C's and everything. Okay, what I'm going to do now is open up, open up my GitHub program that I have on this computer. GitHub, and I'm going to, I wonder if this works. Make it faster. I'm going to take the files and I'm going to say week demos, and I'm going to commit these. Oops. And then sync. Where is? Oh, I was looking at the wrong thing. Okay, so let's just that's another program I'm working on. Week 2 demos. What I'm doing here, by the way, is I'm adding all of the code that I just created up onto GitHub. So now, when you go to GitHub online, when you go to the class, too many things open here. Okay, there we go. When you go to the course GitHub, if you go here to this and hit refresh, it should have, yeah, all the examples that we went over today. So there's all that Python code that we went over today that you can now get at. Okay, so the program that we just created, the program we spend the most time on is program 4. So you can see all the code for program 4. It's right there. So you got access to that. Okay. All right. We can do a few things. Anytime that we want to change the value of what it tests, we could just do that by replacing, like, let's say this with R. Okay, and we run this again, and we'd be testing R. Okay, there's 2 R's in that one. All right. Okay. Take that back. Okay. Let's look at what I'm looking for here. Yeah, the outline. Read me. So this is the outline for week 2. See where we are. Okay, we talked about all these concepts. I didn't call it incremental development, but one of the reasons why functions are so great is because we can write our code as functions, and then we can evaluate just that function, see if that function works. So when we're writing more complex programs, if we break our programs out into functions, then they're easier to test, and they're easier to build slowly, or not necessarily slowly. They're easier to build in pieces than they are to just write a big, long program that does something. If you separate it out into, okay, I need a function that does this task, I need a function that does this task, and then you combine those tasks to your overall program, it's much better. And that's a programming style that's referred to as incremental development. So it's one reason that writing functions is helpful. And then we did already discuss composition is a fancy way to say that allows you to label part of your code, okay, and call it something like, in our case, count letters. That sounds like if somebody goes about reading our code here, oops, somebody goes about reading our code, or is it Python? There. Somebody goes about reading our code, they understand what this function does because it's called count letters. If I didn't have that function there, when I got to this point, I might not, if I had all this code just down there like I had it before, it wouldn't be as readable. And so that contributes to composition, okay? Also something that we didn't demonstrate yet, but you could now see how you could write a function that would return a true or false value. And in fact, on that note, let's look at what the lab assignment is, okay? The lab assignment for today. And in fact, we'll do this first one together. It's going to be a function that's going to end up returning a true or false value, okay? Okay, so we've got 3 assignments here. And also, in addition to these assignments, I would highly recommend that you go through the book and do the examples that are listed there. You don't need to turn any of those in. You only turn these in. But the book examples will help you out a lot. You could probably skip over the parts that talk about recursion for now. Recursion, that's the 3rd way to do looping. It's a very powerful way to do looping, but we're not going to utilize it as much in what we do. We're going to loop over variables. We're going to use lots of for statements. So if you don't really want to understand recursion right now, You can skip over those parts. It is a pretty cool concept, but we don't need to discuss it much further in this class. Okay. So I would recommend you do this. This first example is actually, the first program that I'm having you write is actually one of the ones from the book. The other two are not in the book. Okay. The other two are actually closely related to geography. So we're getting into geography here. But the first one is this one, and it actually is kind of related to geography. In order to find distances and things like that, you have to do lots of things with triangles. And so we're kind of getting into introducing people to triangles here a little bit. And basically what we're going to do is find out if any three sticks that have certain lengths can make a triangle. Okay. And if you think about it, any sticks can make a triangle as long as there are as long as the sum of any two of the sticks, okay, if any three lengths is greater than the sum of any of the other two, then you cannot form a triangle. So basically, well, I was about to say it the opposite way. If any two sticks are shorter than the third stick, you can't form a triangle. Okay, kind of try to picture that in your head. If you had a stick that was 5 inches and you had two sticks that were 2 inches, those two sticks would never touch anywhere, right? They'd be like, I mean, even if you rotated them all around in a circle, they would never touch. But if you had a stick that was 5 inches and you had one stick that was 2 inches and one stick that was 3.1 inches, it would be a very flat triangle, but it would still form a triangle. So as long as you have any two sticks that are longer than the third stick, then you'll be successful in forming a triangle. Okay. So there's a few statements to check here. So we have to think about how we're going to solve this problem. We have 3 sticks, and we need to check every possible combination. And if all of the possible combinations of, holding 2 sticks out and leaving 1 stick in and comparing the lengths, if every possible combination works, then it's going to be a triangle. If any of them fail, is it a triangle? No. It only works is if all of those possible combinations work. Okay. And there aren't that many to test. How many are there to test? So let's say that we are going to call the sides of our triangle A, B, and C. Okay, we've got our sides of our triangle A, B, and C. We need to test whether or not A and B are longer than C, right? We need to test whether or not B and C are longer than A, and we need to test whether A and C are longer than B. Okay, so there's really only those 3 things to check. There's the number of sides, which in this case is 3. So there's not a whole lot, but all 3 of those need to be true, and then we'll check them. Okay, so those are the possible. So we're going to write a function named isTriangle that takes 3 integers as arguments and then prints either yes or no, depending on whether or not you can form a triangle from 3 sticks with the given lengths. Okay. You don't have to write it this way, but I think it's best practice is to actually have the function isTriangle return a true or false. Is it a triangle? True. Is it a triangle? False. And then outside of the function, you report the value, whether or not you can say it. If it's true, say it is a triangle. If false, it's not a triangle. Okay. All right. Then really, you're going to turn in one function for this, and the final function also has to let the user enter their own 3 lengths. So you're going to enter in 3 lengths, and it's going to return whether or not that can be a triangle. So the user is going to actually input it. It's probably best to first write the program without the user inputting it and then modify it to do that. Okay, it's just easier, but you only have to turn in the final program. Okay. All right, so that's the first one. And that one we'll do mostly together. We'll do most of that together in class. But even though we're doing it together, I'm going to tell you right now, the gotcha on that one is that you have to be careful about what raw input returns. Does anybody have an idea of what it might return? Raw input, this function right here. Where did I put it? Raw input. What does that function return? Okay, when I typed in George, it put George inside of name 1. Okay, what type of variable was name 1? String, the character string. Yeah, it was a string. Okay, so it's going to be a string. And even if you type in 5, it's going to be a string. Okay, so you need to convert that value. Your book will help you do it a little more elegantly, but you could just type in int and then the output, name 1. Okay, of course, it'll give you an error if it can't convert it. So I could say, you know, side 1 equals int. Okay, so that's going to convert it from an integer. I don't want it to actually be an integer. I want to let them put in float values. Okay, float values. Okay. You could actually test whether or not it's a number, but you don't have to get that. You don't have to go that far. If you say enter the length of a triangle and they write they type in George, and your computer creates an error, it's kind of the user's fault because you told them to enter the name of a side of a triangle, not a name. Okay, so they enter a name and they get it. We'll do that one together. All right. Now, these next two, those next two are both about calculating distance. Okay. There's actually a formula in the book that allows you to calculate distance. It's not a hard. You could write the function yourself probably. Okay. The function for distance is related to the Pythagorean theorem, a squared plus b squared equals c squared. But I want you to go look at that function in the book and write a program that calculates the length of a polyline. Okay? A polyline is actually a line with lots of vertices. So you're calculating the length of a line that uses lots of vertices. And you're going to use a while loop to continually prompt the user to enter a new vertex along the line. So they need to enter the x and the y coordinate, basically. And we'll start this one. Okay. Each time the user should be asked if the polyline is complete. If it's complete, report the length of the line. So we're going to kind of modify this one where we have, whoops. I'm getting too much. I should have had less open. We're going to modify this example 3 because this example 3 already does a while loop. But we're going to change this so that it actually prompts you for x and a y value. Okay. And then finally, we're going to modify that program to, instead of calculating the distances in Cartesian coordinates. Okay. Anybody know the distance from? Well, of course you don't know the distance, but if I were to calculate the distance from Los Angeles to London, okay, what is that distance? Well, if I calculate it in meters from Los Angeles to London, hopefully I'm talking about going over the surface of the globe, right? Okay. Well, I've given you a function that actually calculates that distance along the surface of the globe rather than calculating it as Cartesian, you know, a squared plus b squared equals c squared. You don't have to understand how the function works. I've given you that function. Actually, I even told you I took it. That's this function, right? I thought I still had that up. Is GitHub not going on right now? Oh, there it is. There's GitHub. So that's this function right here. If you go to week 2 and you go to this Habersign function, this function takes a it takes two coordinates and returns the distance in meters along the globe. in kilometers, sorry, in kilometers. And I just actually took this right from Wikipedia, actually had an article on how to calculate it, okay? So I took that function from there. And we'll demonstrate how that function works, and then it'll be your responsibility to implement that into a program. Okay, so let's start off with the first one. All right, but before I do that, I'm going to get to Daryl's question. An error has occurred. So let's go ahead and stop this one, because it looks like this one is not working very well. Stop.